Hello, in this short video we're going to discuss surface preparation in CONVERGE Studio. Surface preparation involves getting rid of all the surface defects that might exist in your geometry, and then preparing your geometry for the case setup process. At the end of this video, you'll be confident identifying different types of surface defects and various ways you can resolve them. To discover the different types of surface defects that might exist in your geometry, go to the diagnosis dock in the CONVERGE Studio and click on Find. The diagnosis dock will be on the right side of your screen, and if it's not showing up there, you can go to the View tab and toggle it on. After we've clicked Find, we can see that several errors show up in the diagnosis dock, and they are highlighted in a magenta color on the geometry. We'll proceed with the simple wind tunnel case to demonstrate the different types of defects and how to fix them. First, we'll go through the fatal surface defects as identified by the diagnosis dock that'll prevent CONVERGE from running. First, we'll go over intersections. Intersections are defined as defects that occur when triangles pass through one another. We can see an example here as these fan blades pass through the wall. To better see them, we can either hit Show with Neighbor or Show to isolate the problem triangles. Right-click and hit Redisplay to show the rest of your geometry. Next, non-manifold problems are caused by edges that border more than two triangles. They are also known as T-junctions. You can see it here as these green triangles make a T-junction with these two wall boundaries. Next, normal orientation errors are caused by triangles whose normal vectors are inconsistent with the normal vectors of adjacent triangles per the right-hand rule. The normal vectors for each triangle must point toward the computational domain. So in this case, that is the interior of the geometry. To quickly see the direction of the normals, click this Toggle Normal button on the left side of the screen, and now we can see which way the normals are pointing. Finally, open edges are defined as edges that border only one triangle. You can see them here. This will be highlighted in this orange with the magenta triangles here. It usually shows up as a hole in the geometry. All of these defects can be classified as fatal defects, meaning CONVERGE will not be able to run when even one of these defects is present. Thus, it is imperative to repair these defects in the geometry before proceeding. Before we move on how to fix these fatal defects, we'll go through some of the lesser-known defects that might exist in your geometry. While these defects aren't fatal, they might still hamper your simulation by causing recoveries and divergence issues. So it's a good practice to keep note of these defects as well. You can find these defects by using the diagnosis dock as well. Overlapping triangles are triangles that meet other triangles at an angle less than the user-specified tolerance. Isolated triangles are essentially one or more triangles surrounded by neighboring triangles that are flagged to different boundaries. Due to this, isolated triangles may cause issues with the boundary conditions. Aspect ratio refers to the triangles with a poor aspect ratio. Small area corresponds to triangles whose area is smaller than the user-specified value. And similarly, a small angle corresponds to triangles that contain at least one angle less than the user-specified tolerance. Moving back to the fatal defects, we can repair all these defects we have discussed using many geometry manipulation tools available in CONVERGE Studio. Intersections, for example, can frequently be resolved by strategically deleting and recreating triangles or transforming them. In this case, to get rid of these intersections, we'll go to Transform and scale by a factor of 0.75 on the boundary that makes up the propellers. To apply that, we no longer see them. And to confirm that we've solved these problem triangles, we'll click Find and now we'll see a green check mark next to the intersections and a 0, meaning there are 0 problem triangles due to intersections. Non-manifold problems can be resolved by removing the T-junctions that exist in the geometry. In this case, we'll just remove all of the triangles in the middle here. Luckily, they are all not assigned, so we can go to Repair, Delete, select the non-assigned triangles, and click Apply, removing them all with one click. And then we can click Find again to see that the problems have been solved. Moving on to open edges, we can quickly resolve these by using the patch option and selecting by open edge within the selection dropdown. This will allow us to easily select the open edge and click Apply. We want to be mindful of assigning the new triangles from your patch to the correct boundary. We'll hit Find again to confirm that we have solved those problems. And lastly, normal orientation. Problems are pretty straightforward to resolve. First, toggle your normal so you can see them. And then we'll go to Transform, Normal, select a single triangle because we have propagate change from a single face selected, and that should fix all of the problem triangles due to normal orientation error. Visually, we can see it. We'll click Find once again to confirm. Using these simple and effective tools, you can clean up any complex geometry you encounter in your line of work. You can minimize surface cleanup in CONVERGE Studio by following some of the best practices we prescribed while working in your CAD program. First, when creating the surface, try to increase the resolution in areas of sharp curvature. Next, you should also ensure that each circle is represented by a sufficient number of vertices to avoid cylindrical shapes that look like prisms. Next, always verify the solid is watertight to avoid any open edge errors. And lastly, one should optimize the total number of triangles because excess triangles increase simulation time, while too few triangles may not capture important surface features. Keeping these best practices in mind will drastically reduce the time required to clean up your geometry, granting you more time to focus on other aspects of the simulation. That brings us to the end of this surface cleanup video. And for more details on these tools, please refer to our in-depth training materials and user manuals on the Convergence Science Hub. Thank you for watching.